Hey guys, today we're going to do 1-5 solving inequalities. Our objectives are to solve and graph inequalities and to write and solve compound inequalities. The essential understanding: just as you use properties of equality to solve equations, you can use properties of inequalities to solve inequalities. These key concepts. So, the inequality x is greater than 4, the word sentence is x is greater than 4. This is greater than, this is greater than or equal to. Or equal to, you can see that we have a line underneath that caret. When we look at the graph, when it is just greater than, we have an open circle and an arrow pointed towards the direction of the greater values. Greater than or equal to, we have a closed circle with an arrow pointed towards the greater values. Less than, the caret goes the other way, still an open circle, and our arrow goes the other way. Less than or equal to, now we have the line under our inequality, so we have a closed circle and the arrow going towards the less than values. Writing an inequality from a sentence. What inequality represents the sentence 5 fewer than a number is at least 12? So 5 fewer than a number is the number minus 5 is at least, which means it can be more, but it is not less than 12. So it could be greater than or equal to 12. And that's how we take the sentence and write it into an inequality. Properties of inequalities. Transitive, addition, subtraction, multiplication. These are very similar to the ones of the ones just like with an equal sign. So if we add to one side, we have to add to the other. If we subtract from one side, we have to subtract from the other. If we add, if we're multiplying by a positive number, then the inequality sign stays the same. But if we are multiplying by a negative number, then we have to flip the inequality. And that's the same for division as well. So if we're dividing or multiplying both sides of our inequality by a negative number, we have to flip our inequality sign. What is the solution of negative 3 times 2x minus 5 plus 1 is greater than or equal to 4? Then we have to graph our solution. So I'm going to distribute negative 6x plus 15 plus 1 is greater than or equal to 4. Negative 6x plus 16 greater than or equal to 4. Subtract 16. Negative 6x is greater than or equal to negative 12. Now I'm dividing by negative 6. When I'm dividing by negative 6, I get x. And instead of greater than or equal to, here I'm going to put less than or equal to. Negative 12 divided by negative 6 is 2. To graph that, I have a number line, 0, 1, 2. On 2, I am going to put a closed circle, and the values less than or equal to 2 are the values to the left. Using an inequality, a movie rental company offers 2 subscription plans. You can pay $36 a month and rent as many movies as desired, or you can pay $15 a month and $1.50 to rent each movie. How many movies must you rent in a month for the first plan to cost less than the second plan? So, $36 a month, rent as many movies as you want. Or, you want this to be less than $15 per month plus $1.50 for each movie you rent. So we want to know how many movies we need to rent in order for the first plan to be cheaper. So we're going to solve the equation, the inequality. I'm going to divide by 1.5. So n is greater than or equal to 14. So once you rent 14, I'm sorry, not or equal to. I'm not sure where this or equal to came from. It would just be greater than 14. So once you have rent more than 14 movies, the first plan will be cheaper than the second plan. Problem 4, no solution or all real solutions, all real numbers as solutions. Is the inequality always, sometimes, or never true? Just like we were doing with equations, we have to simplify first. So we get negative 6x minus 2 is greater than negative 6x plus 7. Add 6x. Negative 2 is greater than 7. Is negative 2 greater than 7? No. So this is never true. Here we distribute the 5. 10x minus 15 minus 7x is less than or equal to 3x plus 8. 3x minus 15 is less than or equal to 3x plus 8. Subtract 3x from both sides. Is negative 15 less than or equal to 8? Yes. So this is always true. You can join two inequalities with the word and or the word or to form a compound inequality. To solve a compound inequality containing and, we find all of the values of the variable that make both inequalities true. So what is the solution of 7 is less than 2x plus 1 and 3x is less than 18? We're going to graph the solution. So we're going to solve both separately. 7 is less than 2x plus 1. X is greater than 3 for the first inequality. Then we want 3x is less than 18. Divide by 3. X is less than or equal to 6. So all of our solutions when we have and need to be fitting both of those conditions. So if you graph x is greater than 3, so open circle, and x is less than or equal to 6, so I have a closed circle. Now, where do these two solutions overlap? Well, it can be from 3 to 6. So we can also write that in interval notation. A parenthesis goes with the open circle at 3 to 6 with a bracket because it is a closed circle. You can collapse a compound and inequality like 5 is less than x plus 1 and x plus 1 is less than 13 into a simpler form where 5 is less than x plus 1, which is less than 13. And you read this as x plus 1 is greater than 5 and less than 13. When we're solving an or inequality, your solution needs to satisfy either of the two inequalities. So we're going to solve them together. Both separately. So then solve for k. K is greater than or equal to negative 1. Or 8 plus k is less than 3. Subtract 8. K is less than negative 5. So those are our two conditions, and when we graph it, K is less than negative 5, 5, so I'm going to -5, open circle, arrow to the left. K is greater than or equal to -1, -1, closed circle, arrow to the right. And that is displaying our solutions for this OR inequality. Now you guys try this one.